Module 12, Searching by Reaction Scheme.
As a capstone assignment in an organic chemistry laboratory, you may be asked to find and transcribe a published experimental procedure from the primary literature. Scifinder allows you to search the primary literature for any published reactions, no matter how simple or complex. This current module will address how to use the drawing editor to search for general reactions in the Scifinder database. So, if you have not yet completed Module 11, return to it now so that you will be prepared for the current module. To demonstrate searching by reaction structure, we will use a Grignard reaction of acetophenone, a common reagent in commercial synthetic processes. Click Reaction Structure at the bottom of the left-hand toolbar on the main Scifinder webpage and open the drawing editor as in the previous module. First, click on the benzene tool and click on the drawing pad. Then attach an ethyl group and now we'll add the carbonyl. To draw a double bond, click on the double bond icon in the horizontal toolbar on the bottom of the editor. Then draw a double bond from the benzylic position. Finally, click on the oxygen atom in the element toolbar and click on the end of the double bond where you want that oxygen to go. Alternatively, you can transform a single bond into a double bond by selecting the double bond tool, hovering your mouse over a single bond until it turns red, and clicking. In organic chemistry, we understand that reactions are not specific to only one substrate. However, unless you instruct Scifinder to look for general structures, it will search for the reaction exactly as you have drawn it in the editor. There are several ways of generalizing these structures, although we will be unable to cover all of them in this module. So let's just focus on the aromatic ring first. The aromatic ring, for example, could have been substituted by various halogen atoms in any of the ortho, meta, or para positions. So, to generalize the current reaction search, click on the Variable menu icon in the vertical toolbar. Click on any halogen and close the window. Click underneath the benzene ring to place an X near the ring. Now you can show its general attachment to the ring by using the Variable Attachment Point tool. But first, make sure you're using the single bond to draw the attachment to the ring. Then, click the Variable Attachment Point tool and starting from the X, drag from the X to carbons 2 through 6 on the ring, releasing your mouse when the red dot appears. Now that you've finished drawing the starting material, select your structure using the lasso tool and use traditional Microsoft commands to copy and paste an identical structure into the drawing editor, which will serve as your product. But in the second structure, we'll need to change the ketone into an alcohol. Choose the single bond tool and click on the double bond until it becomes single again. Add a bond to hydrogen to make the alcohol. Then draw a bond to the carbonyl where the Grignard agent must have attacked. And if you've ever inserted the wrong atom, you can always click on the desired atom beneath the editor, click where it's supposed to go, and voila, like I've done here. We will represent the Grignard reagent that added as a general alkyl chain. Using the Variable menu tool, choose any alkyl chain. Click at the end of the bond that was just made to add the general alkyl group. Two structures now exist on your drawing template, acetophenone and 1-phenylethanol. You must assign each of these molecules roles in the reaction. Click the Reaction Role icon, hover your mouse over the left-hand molecule until it's highlighted in red, and single-click. A message will ask you to define the role. It is advisable that you select reactant or reagent for your starting material. Now define the role of the product in the reaction. After your structures are complete and assigned, on the right-hand side of the drawing editor, select to Get Reactions, where the structures are only variable at the specified positions. Then click OK. Under Advanced Search Options, you'll see that there are several limits that can be placed on your search, but most importantly, we'll want to limit the number of steps in the reaction to 1, just like we did in the previous module. Then click the Search button to retrieve your reaction list. 243 reactions fit the criteria for this search, but if we further refine by a good product yield as we did in Module 11, our list is reduced to 143 reactions. Now, many of these hits are from the same articles, so it would be somewhat repetitive to view all 143 across these 10 pages. Instead, if you group by document, you'll only see one reaction per article, reducing the number of displayed reactions over only 6 pages, a somewhat more manageable list to peruse. Finally, to access a reference and to find it at Rider or at another university's library, click on the hyperlink title to view the full bibliographic information and access the articles as you learned in previous modules. Congratulations! After 12 modules, you should be equipped with all the tools you need to search for a topic, chemical, or reaction, and to find relevant primary and secondary literature references at Rider University or other libraries. If you're not yet fluent in these methods and encounter trouble during your literature search, you should return to this tutorial for extra help. You can also make appointments with any of the chemistry faculty or your science librarian, Patricia Dawson. In the next module, Module 13, you'll be given a brief lesson on the parts of a scholarly chemistry article. You'll find guidelines for effective reading and extraction of important information, as well as tips on how to think critically about the material for your final research report.